Welcome to the results, graphs, and data analysis video. This goes hand in hand with the previous video. In this video, we're going to take the raw data from the last video and start to analyze it with visual graphs.
So now I'm going to demonstrate how to make a table and graph in Google Sheets, as it's a very easy platform to record data and analyze it. So this is a blank demo data gathering sheet that you guys will get and have access to. And in order to work with this, you actually have to make a copy of this blank demo data gathering sheet. So what you can do is go up to File and then press make a copy and just press OK. So once you do that, you can name this document whatever you want. I'm just going to name it Protham Data Gathering. And what you have to do first is replace these independent variable levels with your independent variable. So what we got in the last video was this table over here with all the data. And so you can see our first independent variable is the rubber tire. And so we can just replace that. And you can also see that our second independent variable was the plastic tire. So we can also, so since we only have two independent variables, we can just take this one out. But you can always copy and delete these little tiny sections as you see fit to your independent variables. Next, we're just going to fill in the purpose of this table, which is the balloon car distance. And that's it in terms of labeling your graph. Now we can fill in the data. So we have this right here for rubber tire, and that just fills in right there. And then we have this over here, which is a plastic tire, and we can just, again, copy and paste this from our table. Now, you can see that we have this trial 1, trial 2, and trial 3, and explained in the last video, this is just to have a good, accurate data set. And we can see that in trial 1 for the rubber tire, we got 6 inches and so on and so forth. Right here, we have this little average, and this average is basically all these data values combined. So 6 plus 6.5 plus 6.25, you get that sum, and then you divide it by the amount of trials you have, which is 3 in this case. And so you can see that value equals 6.25. You can also have a little neat trick in, cut that out. Here's a little neat trick. And to calculate the average, you can just do equals average, and then in parentheses, the certain set of data. So in this one, it's B2 to B4. What this basically means is just column B, row 2, column B, row 3, column B, row 4. And so it just includes that little square of data, and it gets the average of that, which is just 6.25. And you can just do that for all your independent variables. Now we're just going to create a data chart. So what we can do is go to Insert over here, click on Chart, and we have this right here. So first, what we have to do is select the data range. And what this data range is it just includes all the data that you have. And so our data range in this one is A1 right over here to C5. So I'm just going to put that in. And once we do that, you can see all our data is inputted. The next thing I want to talk about is the chart type. And basically, there are different types of charts, such as bar charts, or in some word cases, column charts, line charts, bar charts, pie charts, and scatter charts. And all of these are just different variations to showcase your data. And different types of graphs suit different types of data needs. So in this case, I'm just going to keep it as a column chart because I think it's very adequatable for this type of data, and Sid's going to explain the rest.
So expanding on the chart style that you choose for your data, different types of data suit different types of charts. For example, if your trials include an aspect of time in them, then a line chart may be useful. Or if you just have a trial that has a singular value, for like in this case, then a bar chart might be more useful. So as you can see on my screen right here, on the right side is where you'll see this chart editor, which is what Pratham went over. And on the right side, you actually see all the customization parts. So the first one up here is chart style. Here you kind of just change the aesthetics of the chart, so you can change the background color, the chart border, and the font size. So it's mainly just aesthetics. And there's these things at the bottom just kind of indicate things that are specific to that graph. Um, then we have our chart and axis titles. So at the top here, we don't actually have a title right now. So for in this case, we would probably have balloon bar distance, and that would be our title. And over here, this is just some more customizable like aesthetic features. It's very important to make sure that your chart title is descriptive enough to explain what is going on in the chart. The person trying to comprehend your data should know what they're looking at, and the chart title has that responsibility of conveying that. Then we have your axis titles. So your axis titles are going to describe what actually is, the axis is actually describing what the numerical values represent. So on the y-axis, you would have inches, since the distance of the car is measured in inches, and that's what is being represented in the y-axis. On the bottom here, we already have trials, so that would likely be your horizontal axis title. And once again, we have some customizable aesthetic features. Next up, we have the series section. So this, I'm going to start down here. So this trend line, you'll notice that there's a trend line on the bar graph, which isn't normally used with a trend on a bar graph, but this mainly pertains to a line chart. So whenever you have a line graph, you'll have kind of obviously a line, and that kind of doesn't always tend to be a straight line. So what the trend line enables you to do is it kind of gives you an average line. It's a straight line, and it represents the average of all the data that you have on this chart. This also applies for a scatter plot. So over here, this series, this kind of, once again, this is mainly some more aesthetic features, since it, dash type, how things look, line thickness, color, things of that sort. And our next section is the legend. So the legend, this is also another key part of the graph, which conveys a really important part of your graph, because it tells you what color represents what independent variable. So as you can see on this graph, this is the legend right here. The legend tells you which color is associated with which variable of our experiment. So in this case, the blue color represents the data value associated with the rubber tire independent variable, and the red color indicates the plastic tire, which is the other independent variable of the experiment. And once again, as always, there's the aesthetic customizable feature here. And earlier we talked about the axis title. Here down this horizontal axis is a little bit more detailed for specifically the horizontal axis. So this is mainly just more aesthetic stuff, as always. I mean, hence the name, it says customized. So most of this stuff is aesthetic, but there are a few key things in here that are important, which is the main reason why we're going over this. And now the same thing applies to the vertical axis. So it changes how things look on here. And finally, we have the grid lines and ticks. So this kind of splits up your axes in a way that makes it easier to comprehend your data. So in this case, it's not really that difficult because our range goes from 0 to 8, so it's not that bad. But if you have, really wide range values, you might want to add more grid lines just to make the comprehension of the reader a little bit more easier. And once again, as always, there are more aesthetical customizable features here. I do say aesthetic features a lot in here, and I do think it's important that you change some of them on the graph because it makes it a little bit more visually pleasing, and which in turn makes it a little bit easier to comprehend the graph, which is always important since that is the point of your graph. But at the same time, you shouldn't go overboard, right? You shouldn't care about changing the font size by 1 point. That's not really what the point of the graph is, right? You're just trying to make it as simple as possible and make it as easy as possible for the person looking at your graph to comprehend it. And whenever you create these graphs and as well as your tables, you'll include these on your final report eventually. And you'll have a small box that describes what is actually being conveyed and interpreting the data for the person going over your final report. This is the data analysis of your graphs and your tables. This is important because it shows the person what you actually concluded from the set of data and how it's being represented. And now Pratham will conclude this section off so that we can move into the next part about data analysis.
So this is just a basic demo of how to use Google Spreadsheets to record data and make graphs and tables. So this is just a slide with the template link on there. And if you do have any questions, you can always email us. But next, we are going to talk about what to do with this data.
So now we're going to move on to the data analysis portion of this video. So here you're going to analyze the relationship between the independent variable and the dependent variable. And this is the main reason that we created the graphs in the first place. It's really hard to look at just your raw data and establish a relationship, but through the trend lines and the bar graphs and the scatter plots and everything that Siddhartha and Pratham just talked about, you will get an idea of how your independent variable is related to your dependent variable and vice versa. So there are four main types of formal relationships between the two variables. These are a proportional relationship, an inversely proportional relationship, a positively correlated relationship, and a negatively correlated relationship. In addition to this, there's also a zero correlation relationship. Jay is now going to talk about the first type of relationship.
The first type of the relationship is a positively correlated relationship. In this case, when the independent variable x changes, the dependent variable y will display a similar type of change. For example, your independent variable x may increase, so will your dependent variable y, but not at the same rate. In a positively correlated relationship, the exact change in the independent variable is directly reflected by the dependent variable. A good example of this is running on a treadmill. The more you run on a treadmill, the more calories you burn. Seisha will talk about the next type of relationship.
So the second type of relationship is a proportional relationship. And this basically means that as your x variable or your independent variable increases, so will your dependent variable at the exact same rate. For example, if your independent variable were to get doubled, then your dependent variable would also get exactly double. And this is the essential part of a proportional relationship. It means that your x and your x variable and your y variable, your independent variable and your dependent variable, will have the exact same rate of change. Now, of course, in the real world, your data might show that the relationship is a bit off than exactly double or exactly the same rate of change. And this is fine and may be controlled by, and maybe due to the fact that your control variables might not encompass everything that your experiment is affected by and things like that. So this is also another reason why you should perform 3 trials of your experiment so that you can have a better idea of how proportional your relationship actually is. Next, Pratham is going to talk about the third type of relationship.
So the third type of relationship is a negatively correlated relationship. In this case, your independent variable x may increase, but your dependent variable y will decrease. But this won't happen at the same rate. In negatively correlated relationship, the exact change in the independent variable is directly reflected by the dependent variable. A good example of this is student absences. For example, a student with more absences will probably have lower grades, but these are not changed at the same rate. Jay will now talk about the fourth type of relationship.
The fourth type of a relationship is an inversely proportional relationship. This basically means that as you multiply your independent variable by some value, your dependent variable is getting divided by that same value. For example, as your independent variable doubles, your dependent variable is divided by 2. Similar to a proportional relationship, a negative linear relationship also describes the same relationship as a inversely proportional relationship. It has a negative slope. This is because a proportional relationship describes a relationship with the same rate of change. Essentially, an inversely proportional relationship, similar to a proportional relationship, describes a special case of a negatively correlated relationship. Again, this is the real world, and sometimes these values can be like 0.1 off, but that's fine. If you think about conceptually and realize that it makes sense for your data to be inversely proportional, you can state that. Next, Siddharth will talk about a special type of relationship.
This special type of relationship is called zero correlation. This type of relationship indicates that there's no correlation between the independent variable and the dependent variable. The changes in the independent and dependent variable are completely unrelated. There is a chance that the data obtained from your experiment may have this relationship. It's important to try to identify any flaws in your experiment that may have been a cause for this. But regardless, whether or not the experiment is flawed, the fact that your data has zero correlation should be stated. Just because you have zero correlation doesn't have to mean that there was something wrong with your experiment. The purpose of your experiment is to identify the relationship between the variables. And if there is no relationship, then that is the conclusion you can make from your data.
But this brings us to the end of the video. And next time we're going to be talking about your conclusion, your application in the real world, your recommendations, and your bibliography. As always, if you have any questions, feel free to email us at the email on the screen and drop a comment below. This is Science Squad signing off. Thank you for watching and see you in the next one.